Traditional computer science is based on logic, in which everything has a precise, well-defined state. But today, computers have to deal with many tasks involving ambiguity and uncertainty. Now, the key to building intelligent machines is to embrace this uncertainty and to quantify it using probability theory. This exhibit will showcase new applications of machine intelligence and will highlight a powerful new approach to probabilistic computation. Every demonstration will be strongly interactive, giving visitors the chance to interrogate for themselves the science of uncertainty.
This is Live Object, a system for recognizing objects placed in front of a camera. Rather than having to be programmed with rules on how to recognize what object you've put down, the system learns from examples. So you just place down objects in front of the camera and it will recognize them. Then later you can place in a new object, like say a can, and put that in front of the camera. Then you tell it what the name of the new object is, and now the system has recognized that as a can.
This is our medical image viewer, which allows users to navigate through complex 3D medical images, such as 3D CT scans of patients. And this is our tool, which allows doctors to localize anomalies such as tumors and quantify them, and for instance assess whether they have grown or shrunk with respect to last week. And I can just click on the tumor in the liver in this case, and the segmentation happens very quickly in front of your eyes.
One of the things we've been working on in the lab for quite a few years is how to make image processing operations for inexpert users. Underneath the hood, what we have running is probabilistically based software, which has to be probabilistic in order to deal with the inherent ambiguity in images. Here the task is to take this turtle, which was photographed in a particular background, and to replace it in a new environment. And in order to achieve this, click on the image and select background removal. You see the task is more or less done for me. It can be picked up and carried somewhere else. To make it seem even more like it's in its natural habitat, then I can add shadowing. I'm going to drop the turtle into the document. I can exploit the fact that we have just done the accurate cutout and make something that fits much more nicely. Here we are.
Visitors to the exhibit who are not familiar with probabilities can have a go with the Galton machine, seen here during the Royal Institution Christmas lectures. If they drop a single bead into the machine, it bounces around in a random-looking way, and we can't predict where it will end up. But if they pour 1,000 beads into the machine, we see that they build up into a very precise curve. Now, it's curves like these which form the mathematical basis for all of the technology which you'll see at this exhibit. Other hands-on demonstrations will allow visitors to see how the probabilities change as they add more information. Here, users can explore how changes in the results of a drug trial influence the probability that the drug is effective. As more people participate in the trial, the distributions become narrower, reflecting a reduction in uncertainty. The applications presented in this exhibit use high-resolution images and video streams involving megabytes of data. Increasingly, however, we need to deal with data sets which are thousands of times larger. Recent work at Microsoft Research and elsewhere has created a new generation of machine intelligence techniques which allow probabilistic methods to be scaled up to exploit the opportunities afforded by the internet and other massive data sources. We have already successfully used these new algorithms for real-time processing of millions of online game results, and in collaboration with colleagues in biomedical sciences, to the search for gene-environment interactions in diseases such as childhood asthma. The final part of our exhibit will highlight these new developments and show how the future of machine intelligence depends on embracing uncertainty.